Hey all, today we're going to continue talking about polygons. This time we're going to talk about some special polygons. We've already talked about the difference between concave and convex, and we're going to stick with talking just about convex polygons now, and a special type of convex polygon that we call regular polygons. The name regular might not make you feel like they're special, but they are. So some things that we know about regular polygons: all the sides are congruent, all the interior angles are congruent, and all the exterior angles are congruent. So I have an example here of a regular polygon. Looks like all the sides are congruent. All these angles look like they're going to be the same inside. And if we were to draw the exterior angles by extending these sides, I'm doing the best I can, and we measured all of those exterior angles would be equal to each other. And over here we can tell pretty quickly that's not a regular pentagon. It still has 5 sides. Both of these things have 5 sides. They're both pentagons. They're both convex. All their vertices sort of point out. But this one you can tell the sides aren't all the same, the angles aren't all the same. And so this guy on the left here is a regular pentagon. The other one is just a pentagon. So we already know how to find the sum of the interior angles of any convex polygon, whether it's regular or not. But now that we know that a polygon's regular, we know all the angles inside should be equal to each other. So we can figure out how big one of them is by finding out the sum and then dividing by the number of sides. So this is what the formula looks like. The top of that, the numerator, hopefully you recognize 180 times n minus 2. That's the sum of the interior angles, SIA. And so since all of them are equal, if we want to find out how big one of them is, we just divide by the number of sides. So you have to be very careful here. You got to make sure that you're plugging in n twice. The common mistake is to divide by 2 here for some reason, and we're not dividing by 2, we're dividing by the number of sides. So here I have a heptagon. It has 7 sides, and so I plug 7 in twice, and I simplify. You might know from practice that there were 900 degrees in a heptagon, a 7-sided polygon. Now that we know it's a regular heptagon, we can divide that 900 degrees by 7 and find out that each angle inside is approximately 128.57 degrees. So that means each of these 128.57, 128.57, 128.57, 128.57, so on and so forth. So let's do another one. I have a hexagon. Got 6 sides. I write my formula every time so that I can remember it. Make sure you're plugging in 6 twice, 6 on top and 6 on the bottom. When we simplify, we get 120 degrees. So again, that's 120, that's 120, that's 120, 120, 120, 120. If you added them all up, you get 720. Because this is a regular hexagon, all of the angles are the same. So I want you to pause here. I want you to find one interior angle in this regular polygon. So hopefully you counted that this thing had 9 sides. It's a nonagon. I'm plugging in 9 twice. Simplifying to get 140 degrees in each of these angles. 140, 140, 140, 140, 140, and so on. 9 140-degree angles. We could do the same thing, same idea for an exterior angle. So I'm using the same polygons. And the formula for an exterior angle is much simpler. The exterior angles in any polygon always add up to 360. in any convex polygon. So if it's regular or it's not regular, doesn't matter. The angles will always add up to 360. What's really nice here is when they're regular, all of them are the same, so we could figure out how big one of them is. So all I need to do to figure out how big one exterior angle is to divide 360 by the number of sides. So this is a heptagon, 7 sides. If I divide the total 360 by 7, I get 51.43. So if I were to go around, and I'm not going to, if I were to go around and draw every single one of these exterior angles, that exterior angle and all the rest of them are each 51.43 degrees. I could do the same thing for my hexagon. I'm just going to divide 360 by 6, and I'll find out that every exterior angle is 60. So again, if I were to draw an exterior angle here, that exterior angle right there is 60 degrees. So I want you to pause, and I want you to find one exterior angle measure in this nonagon. So we need to divide the number of sides, or 360, the total number of degrees, by the number of sides, 9. And you should have gotten that each exterior angle is 40 degrees. So again, drawing an exterior angle, and if I were to measure it, that would be 40 degrees. So you might have noticed this fact here, and I did the same regular polygons in each, the interior and exterior, because I want you to know that any interior angle of a polygon, its corresponding exterior angle, they add up to 180 degrees. They are a linear pair. They're supplementary. So let me draw one here for this heptagon. And you can see that I'm trying my best to make a straight line with this side and that exterior angle. So we have an interior angle here that we found and an exterior angle there that we found. One was 128.57, the other one 51.43. If you add those two things up, you guessed it, they add up to 180. So again, with my hexagon, if I were to draw an exterior angle, again, doing my best to make that a straight line, my interior and my exterior are a linear pair. So if I know one, I know the other. One of them was 120, one is 60. So all that is to say that if I know an interior angle, I could just subtract it from 180 to find the exterior. If I know the exterior, I could subtract it from 180 to find the interior. Or I can lean on those formulas that we had. And let me show you last. The nonagon, exterior angle, again, doing my best to make it straight. And the interior together, they make a straight line. They add to 180. The inside was 140, the outside was 40. So I want you to try one problem. Find the one interior angle for this regular polygon and one exterior angle. If you have questions, make sure you're ready to ask them in class, and you can check your answer.